I know there's some Samsung devices like my friend has that he uses fingerprint authentication, but it's a Samsung device. So is that the same thing or what's the difference here?
Done. Anyone who uses a Samsung phone is not your friend.
Agreed.
Just kidding.
No, you're not. The thing is, you're not kidding, and that's the truth.
All right.
Now, one wrinkle since we mentioned Samsung, though, is that
A wrinkle or like a wave?
Null check, inject, define, APK, lifecycle and design. 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 It's time.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm Kaushik Gopal.
Welcome to the show. On today's show, we talk to Ben Oberkfell about fingerprint authentication. Now, this is a really interesting show because if you have a newer device such as a 5X or a 6P or a Pixel device, and you've implemented fingerprint authentication on that device just to even simply log into the device itself, you probably have realized how useful this feature is. Personally, I use it all the time for my banking applications, my password managers, and various other things that have it enabled. And to me, I can't buy another device again unless it has fingerprint authentication. Now, if your application can benefit from the use of fingerprint auth, maybe you are a financial application, a security-based application, or maybe even something that requires HIPAA compliance, then this episode is going to be very interesting to you. We dive into the details of the trusted execution environment, how to generate key pairs, and what public and private key encryption are, and we get into the real nitty-gritty about fingerprint authentication. We hope you enjoy it.
Before we begin today's show, we want to thank our sponsor for the show, Rollbar. If you've been following along, sometimes we drop a Rollbar tip or two along the way, and this is because we actually use Rollbar in production every day. I use it on the server side, I use it on the backend stuff, I use it on our Android client, and some of the things that I've been able to do with Rollbar have basically become indispensable for me at this point. So today, actually, I want to give you a cheeky tip on how Rollbar can help you keep a clean code base. Now, as I've mentioned in a previous episode, we actually use feature flags at Instacart, and this is quite critical for us to test and roll out functionality. And when you work typically with a large code base and you're moving extremely fast, it becomes a little difficult keeping track of all the different features that are rolling out. For example, if I'm testing a new feature and I create a feature flag, which is also called an experiment flag, and I know that 6 months from now, this experiment or this feature flag is definitely going to be over, right? One way or the other, I'm going to know if this feature or this experiment was either successful or it was a dud and I had to kill the feature, right? So one thing you can do is actually check the current date on your backend. And if it happens to be 6 months from the date that you first pushed this feature out, you can actually throw a rollbar warning. Right? So what does this mean? This means that in 6 months from now, when your feature is done and forgotten, this rollbar will make sure that you come back and clean that code base, removing all the dead code. This is just one of the many, many cool things you can do with rollbar. You can get very creative with your instrumentation. So give rollbar a try today and head on over to rollbar.com/fragmented. And you'll get their Bootstrap plan for free. Make sure to use our special link, that's rollbar.com/fragmented, and they'll know you came from us and it'll help support the show. Thanks again, Rollbar.
Kaushik, I forget, do you have a 6P or a Pixel phone?
I actually have the Pixel.
Really? Do you like it?
Yeah. Oh, I love it. 100%.
Where is the fingerprint scanner on that thing? Is it on the back or is it on the front?
It's on the back. It's on the back. It's exactly like the 6P.
Okay.
It's right at the back.
Do you use it for anything, like logging onto your unlocking or what?
Oh my God. I use it for everything. I absolutely love this thing. It's one of those technologies where once you start using it, you just cannot live life without using it again. I use it for like unlocking my phone. I also use this application called 1Password, where it stores all my passwords. And thankfully, after much online harassing on the web, they have implemented Fingerprint, the Touch ID stuff for 1Password as well. So even when I use 1Password and I have to like pull up a password or something, I use the Fingerprint there. I use it at Starbucks now with Android Pay. Oh, I use it all over the place.
Yeah, it's absolutely fantastic. I got a 6P, and same thing for me. As soon as I started using it, I can't. Like, it's one of those things like I will never buy a phone again if it doesn't have fingerprint support.
Right.
Which brings up a good point. So we have a guest today that should help us dive deep into this topic, right?
Absolutely, yeah. I mean, I think it was Droidcon NYC, where this good gentleman gave a talk about fingerprint ID, and like we've been excited about this for a long time because we've been wanting to talk about this. So without further ado, we should welcome Ben on the show.
Welcome, Ben.
Hi, I'm Ben Oberkfell. I'm really glad to be here. Thanks for having me on.
Ben, for the folks that maybe are not familiar with you, which you are pretty active in the community, can you give us a little bit of background about yourself and kind of where you work and how you kind of got into Android?
Yeah, so I live in St. Louis. I up until recently, worked for American Express, where I helped build the fingerprint login on their app.
Very cool.
And now I work for the New York Times, and I'm building the Android version of the Times Crossword app. So I get paid to do the crosswords, which is really fun. And I got on this journey probably back in 2010 when the Nexus 1 came out, and started goofing around with that. And there was this conference called Google I/O that kind of surfaced on my feed. And the registration window was open for 90 days. So I had plenty of time to decide whether I actually wanted to go or not. It wasn't like the complete free-for-all that it later became. But I fell in love with developing for Android through that, and did some side projects here and there while I was working on cancer research.
Wow.
And then wound up going full-time into this about 4 years ago.
That's cool. No, don't you also work with the GDG in St. Louis, is that correct?
Yeah, I'm the one of the two co-organizers of the St. Louis GDG.
I want to ask you, is the New York Times crossword application an independent application, or is it part of the New York Times app?
It is a separate app, and it actually has a separate subscription, although if you subscribe to the digital news, you get a $20 discount on that sub.
Oh.
But then if you want to buy one-off puzzle packs, we have in-app purchases for those. So if you don't want to commit to a year, you can buy a set of puzzles to play on the train.
That's cool.
Very cool. And we'll add a link to that in the show notes because, I'm a big fan of the New York Times. It's one of the few newspapers that I try to regularly read. All right. So, Ben, we want to talk about the fingerprint stuff because that's the thing that really excites both Don and me. But we want to step back a little because, again, we want to understand as developers, it makes more sense if you sort of understand the hardware as well. Like how does this all happen in the background? So do you think we can start off there? Like maybe talk about how this whole fingerprint authentication mechanism works, like at a hardware level, just to get a brief understanding before we dive into the actual software, which is typically where we try to do all of the magic, right?
How does that fingerprint hardware? We have one on the back of like the 6P and the Pixel and a bunch of other devices on them. How does that stuff work? Do you know?
So some of the older scanners you've seen on maybe the older Samsung phones had an optical sensor, but today's sensors that you'd find on like an iPhone or an Android actually use a capacitive sensor. And so it's kind of like the same sensing that your screen uses, but at a much higher resolution.
Oh.
So there's a grid of capacitors, and the grooves and the valleys and everything in your fingerprint will end up affecting the current that's being passed through. So being able to read out that grid kind of looks like you're forming an image, a grid of pixels. And so that's how you're able to resolve a fingerprint image without actually having to use a camera.
I don't know that.
I had no idea.
Yeah, it actually makes so much sense when you describe it that way. I thought it was actually like a low end kind of camera that actually just stakes an image, really. Because I've heard if you scratch that part, which obviously I imagine now it still won't work, but if you scratch it out, or you've used your phone for some time and it wears out, then that was the reason, because the image that would come would not be of high enough resolution to sort of resolve your fingerprint. So I imagine it's the same thing, but I understand why it happens now. That's amazing.
Yeah, and there is a Qualcomm has a new sensor that can actually handle things like wet fingers and scan through glass and some metals. So you don't actually need that big round circle on the back of your phone anymore. But there's not many devices that have that right now. I think it's just a couple from Xiaomi and Leico. So there's not many hitting major market devices yet.
Oh, that's interesting. And the funny thing is, I've also you mentioned about these valleys and ridges on your finger, right? And it makes sense because I remember I bought my dad a Pixel phone recently as well because he was due for an upgrade. And he mentioned I think he had gone to the pool or something, and after he came back, how your fingers sort of shrivel up once you've been outside for some time. It's actually cool why it happens. I'll put a Reddit thread there for the folks who are curious why it happens. But coming back to the point, so basically, after he tried to unlock his phone with having been outside, it didn't work, and it makes sense now because I imagine those ridges and valleys just completely took a contorted shape.
Yeah. And then the other thing I found too is that if your fingers are wet or even a little bit damp, that can affect the conductivity that it ends up measuring. So if I've just washed my hands, even if I've dried them off, but they're still a little bit moist, that'll affect the sensor sometimes. On some of the Android phones I've used, like my Pixel, then like an iPhone 7, but both of them have their issues of that from time to time.
I think I remember something on, related to fingerprint recognition on episode 38 of Android Developers Backstage podcast. They had mentioned something, and I don't know, the wording may be a little bit off here, but it's something like the chicken wing test.
Oh, yeah, I remember that. Yeah.
They wanted to make sure that the fingerprint authentication in Android would work so well that if you happen to be eating chicken wings and you wiped your finger on a napkin real quick and then you just, put it on the fingerprint sensor, it would still be able to read it very quickly. And so
greasy hands, yeah.
Yeah, greasy hands, exactly. So it was a funny little tidbit from that episode.
I'm imagining sending test devices out to a Super Bowl party and seeing how it goes.
None of them come back working.
Yep.
Now, I've heard that the fingerprint reader is tied to something on the actual chip itself. Do you know anything about that or how that works?
Yeah.
Yeah. So it's called a trusted execution environment, and it's either part of the system itself or, sometimes maybe it might be a separate chip called a secure element. But ARM CPUs have this thing called a trust zone. It's almost like a secure system within a system. And so code on Android can't actually get at the memory what's in the trust zone. And so if there's rogue software running on your phone, maybe you got a virus or you're rooted and you're actively trying to pick at it, you can't exfiltrate what's going on inside that trust zone.
Oh, and so what you're saying is this is actually it's almost like a physical hardware component on your phone, typically for secure sort of phones, where it's almost impossible. They don't allow, say, maybe an API or even at a much lower level, you don't get access to any of that information. There's no reading. There's only probably writing or something along those lines, right?
Yeah, there's channels in and out, but yeah, the Android OS kernel can't actually see what's going on in there or read that memory, or so there have been researchers who have been trying to find ways to break the trust zone barrier.
Mm-hmm.
But in theory,
right.
It's something that's a firewall between the potentially insecure Android world and the world where you're doing things like crypto and fingerprint matching, and actually processing the scanned image and deciding whether it matches something that you have on file.
Got it. Okay, so there's this thing called trust zone, and I imagine trust zone is more of a marketing thing, from the folks at ARM, right? The ARM chip.
You got it.
And the trusted execution environment, that's basically the generic term for where this secure information is held, right?
Right.
So any phone would have a trusted execution environment, any Android phone.
So not everyone.
Oh.
This is something that a lot of older Android phones, this did not have or did not make use of this sort of means of doing secure work and hardware.
Oh.
One thing that you'll find in the Android compatibility definition document, which is a great piece of bedtime reading,
Cure for
Print it
insomnia.
out. Yeah, print it out, keep it on the nightstand. But what this document gives you is it's basically the Bible of what you have to comply with when you ship a version of Android that gets the Google Play Store and all the Google accoutrements that come along with the Android phone that you buy at the store. One of the things that this calls for is how you should build your hardware if you're going to have a fingerprint reader. And so there's things that it calls for, like a fingerprint matching has to happen in a trusted environment, trusted hardware. And then the fingerprint reader has to have a secure channel straight to that, so it can't go kernel or user land on the Android side and on in, and things like that. And then crypto related to fingerprint, which we'll get to later today, I imagine, has to happen in that trust zone as well.
So it seems like there's it kind of bridges the gap into the software component, because the hardware and the software have to talk together. Now, this kind of makes me think of when the 5X and the 6P came out. We had what was called Nexus Imprint, which was like the software and the hardware combination to, from what I understand, allow Nexus phones to support fingerprint authentication. Now, do you know, is this something that all devices have to implement, like something like Nexus Imprint, or is this only specific to Nexus devices? Because I know there's some Samsung devices, like my friend has, that he uses fingerprint authentication, but it's a Samsung device. So is that the same thing, or what's the difference here?
Done. Anyone who uses a Samsung phone is not your friend.
Agreed.
Just kidding.
No, you're not. The thing is, you're not kidding, and that's the truth. We'll get into that in a minute. Don't worry.
So the Nexus Imprint is pretty much, as far as I can tell, it's really just a brand name for the fingerprint framework that arrived in Android 6.
Oh, okay.
And so the underlying implementation for that fingerprint experience is what you'll find in any of the devices that have a fingerprint reader and run Android 6 or better. And so anything that meets those criteria under the CDD and gets a fingerprint reader and all that other good stuff we talked about is going to use the Android SDK that you get in the OS, and it's effectively the same thing. It just doesn't have the fancy brand name.
Got it. So basically, if I understand this right, the CDD is something that's global to all Android phones, and anyone who implements the CDD allows the fingerprint sort of feature on a phone. And Nexus Imprint is essentially a Google implementation of the same CDD, but on the Nexus and Pixel phones. So it's more like a marketing kind of thing, I imagine, right?
You got it. Yep.
All right.
Now, one wrinkle, since we mentioned Samsung, though, is that
A wrinkle or like a wave?
Yeah. So they started doing fingerprint readers back with like the Note 4 and the Galaxy S5,
Mm-hmm.
and their fingerprint API doesn't do any of the sort of really cool crypto stuff that the Nexus Imprint or Android 6 Marshmallow API lets you do.
Mm-hmm.
So it doesn't actually meet the CDD. If you try and use the fingerprint API on one of these devices now that they run Marshmallow,
Mm-hmm.
then you'll find that the OS reports that they don't actually have fingerprint hardware. And you'll probably get some 1-star reviews for this. I know I've seen them on apps that I've used, like 1Password, for instance, where the authors have to go and chime in on their support forums saying, we're really sorry, but these two phones, while they have fingerprint readers, they don't meet the standards that Google set for this SDK, so we can't use them. So that's one thing you're going to have to fight with. Their SDK just is simply a callback of, hey, did you get a successful scan or not? Yay or nay.
Mm-hmm.
So it doesn't have any of the really fun crypto stuff that we're finding in the Android 6 APIs that are really cool.
Okay. So, Ben, what you're basically saying is Samsung phones have weak security in their fingerprint ID, and nobody should ever be using Samsung phones ever in their life. And if they go back for vacations and they're getting new phones for different people, they should not be buying Samsung phones, is basically what you just said, right?
I can't fully agree with that, but I can say if you're going home for the holidays or your family asks you, it's send them in the direction of a pixel.
All right. Okay. I'm clearly a little biased here, but oh well.
Biased, bitter, same thing, right?
Yeah.
That is true. That is true.
We all are. Don't worry. I know.
All right. So so far I'm with you. All this makes sense. So let's maybe like dive into what actually happens now that this fingerprint data like sort of gets encrypted, right? I'm curious about how the encryption model works, because I mean, in all seriousness, this is important, right? Because if you're saying this is like a biometric way of like unlocking your phones and then it's secure, then let's try to understand as developers, like how secure is it really? You know, like, is it really secure? I mean, is it like you mentioned crypto. What exactly is crypto? Like, you know, like I imagine it has something to do with encryption. So can you dive in a little on that?
Yeah, so one of the things that also comes in with the Android CDD, with Android 6 and the fingerprint reader, is that it has to have what's called a hardware keystore. And that's really kind of an abstraction around a place where encryption keys can be placed, and they're not going to be in a place where they can be exfiltrated out of the system by a rogue app, or if you were rooted, or you're the government or whatever else.
Okay.
And so,
sorry, can we step back just a little? What exactly is a keystore for those of us who don't know what a keystore is?
Yeah. So in Android, when you create an encryption key, so either a key that can be used to symmetrically both encrypt and decrypt a piece of data, or if you're doing public-private encryption, where you retain the private key and you give your friends the public key and vice versa. When you generate those keys, those get saved in what's called the keystore.
Okay.
And so it's essentially an abstraction of, a place where the keys wind up being saved. And so some of the older Android devices before 6, and, you go way back in, so like the Jelly Bean, and Gingerbread Dark Days, like they didn't actually have a place in hardware where this key material was saved. So if you were rooted, all bets were off.
Yikes.
And so now what actually happens is that all the key manipulation and the actual cryptography itself happens inside of the trusted execution environment. So
sorry. That's something then we should really like sort of like hit home. So essentially, what you're saying is after a certain API of Android, and I imagine this is M, right? After Android M is when they began enforcing that the encryption happens only inside this trusted execution environment. So even if you got root access to a phone that runs this operating system that is M and above, then you're safe. But if you did before M, then you're probably not.
Right. So, if you end up doing, you have an Android phone that runs M, what you kind of know then is that the private key or a symmetric key for any encryption operation you're going to do is going to be safely locked up in that vault. And it's never going to be able to leave the friendly confines of the trusted execution environment and get out in the world. And so where that plays in, though, is that when you create encryption keys on your device, you can actually set a property on those keys that says that authentication via the fingerprint reader is required before anyone can use those private keys, or before anyone can use the symmetric decryption key if you're doing two-way encryption.
Oh, interesting.
So that's how you can actually use the fingerprint reader to sign data if you're using a public-private key pair, or you can use it to encrypt and decrypt some data you have on disk. And in either case, you have some assurance that the only way you're ever going to be able to actually use those keys and get at that data or sign things is if you actually have put your finger to that reader.
This is actually could be very useful in situations where you need to provide some type of encryption mechanism for maybe like HIPAA compliant data, and you need to encrypt like a local database. Like for example, Realm has AES 256 encryption out of the box, but you need to be able to provide it whatever type of key. You could have it based off of something such as the fingerprint. So if someone wants to have access to your app, but you need to make sure that it's secure to that particular user, you could make them authenticate with the fingerprint and then decrypt and unlock the database at that point.
Yep. You could give, since there's a OS handle for the key, in terms of how it represents it. You could just pass that off to what other API needs the key to do its work.
Exactly. That's so cool.
Got it. Okay. So, sorry, I had a quick dumb follow-up question. So you mentioned that with this key store, you can, with the key that you're encrypting, you can basically set a property saying user fingerprint required, right?
Yes.
So the question then is, well, if you don't have a user fingerprint, because I noticed there are some cases like on your phone where it asks you to enter like a PIN pattern, and like there are other mechanisms of like sort of, or like, the pattern or like a PIN code. So is it an OR kind of thingy, or is it essentially, you can only unlock this with a fingerprint?
So I have not played with it, but as far as I remember, there's also a way to unlock that key using the passcode or the other, effectively anything that can open a lock screen kind of authentication.
Oh, I see. Okay. Oh, okay. So yeah, I imagine they're grouped as like a specific sort of thing. Because I remember there's also this talk about like they're like because smart lock is like this trust agent thing, right? But it's not necessarily as secure. So I imagine there are like these groups of categories which are like, this is super secure, and this is like just like a convenience kind of security.
All right, so we've talked a little bit about the hardware, maybe some of the higher level software stuff, kind of how it works, what maybe we can use it for. But if I'm a developer listening to this podcast and I think this is cool, I really have a use for it, maybe I have that HIPAA use case, or maybe I have a financial app that I need to unlock, or something that has some security stuff. What are some of the things that I need to do to start implementing some fingerprint support? Is there a particular library I need to use? Is there anything of that nature? Or where should I start with first, Ben?
So the first thing you want to do is make sure that you're targeting Android 6 or better in your app. And then once you've done that, you want to go and get a look in the Android SDK documentation and find the Java doc for Fingerprint Manager. And so that has all of the lovely methods you're going to use for checking to see if fingerprint hardware exists, whether or not your device has fingerprints added to it, and then also for performing the authentication. So what also is handy is that the support library gives us a class called Fingerprint Manager Compat, which wraps a lot of this in SDK level safe versions of it. So you don't need all these version checks peppered through your code when you're going to go and do Fingerprint Manager calls.
Oh, nice.
So
nice. Okay.
On older versions of Android, this is going to be a no-op. And then on versions that actually support fingerprint, this will actually call into the Fingerprint Manager and do the real work. I would say, yeah. And so the first thing you want to do in your UI is to be able to query for, hey, does this phone have the hardware? And then you can go and present the user another message saying, oh, you have fingerprints enrolled. Great. Or I see you have a fingerprint reader. If you go and enroll fingerprints in your phone, then we can go and enable fingerprint auth in our app.
And are these like standard UI dialogues that come with the support library, or is this something that you would have to implement?
So you would think that you get this for free with the support library, but that is not so.
Okay.
Yeah, it's never this easy with Android. So if you go to the Android material design guidelines page that Google has, they've got this really great page on fingerprint that gives you some helpful tools on how to design your layouts for standard look and feel, what iconography to use. They have a standard icon that they'd like for you to use across all the apps so that when you enroll a fingerprint, Android says, hey, look for this icon. When you see it, you can use your fingerprint to unlock your phone or unlock this app or anything else that requires a fingerprint operation. So, you can go and start there with some guidelines on what your dialogues should look like, how you can do your designs. And it also has some really good kind of a recap of what sort of fingerprint flows that your user might run into as they're interacting with the app and the fingerprint reader.
Make sure I'm hearing this correctly. There's no like built-in dialogue. So I got to build my own dialogue that looks like material design. So I kind of have to do all that work if I want to implement this.
Yeah, unfortunately so. If you go to the Google samples, they've got a sample fingerprint app that has at least some layout files you can go and pilfer and use yourself. So that's always a good start. But if you look at some of the other apps out there, for instance, one that was a great example that I've seen is the Target app. They have added fingerprint authentication, but they've done, sort of a spin on that dialogue. They've got more of a flat view to it. Instead of, a white on green, kind of an Android green color, they use white on red. It's very Target branded. And the guidelines do say that you can go and use your brand colors, feel free, but just keep that icon somewhere there so that people know what to look for across all the interactions in their phone.
Okay. Now, let me kind of take a step back. We had talked about the Fingerprint Manager and the Fingerprint Manager Compat. You can check to see if the hardware is detected or if it has enrolled fingerprints and all that kind of good stuff, so we can perform different actions given those scenarios. But to even take it back to the fantastic Samsung devices that we all love, what happens with some of those older devices with these methods? If there is a fingerprint reader, is it detected using these methods, or is there any weird things that we should expect, of course, when working with Samsung and fingerprints?
So those older Samsung phones that like the S5 and Note 4, those are going to give you back a false if you query for whether fingerprint hardware exists. And then one thing that I had found on some Samsung phones in crash logs is always fun, is that, and I don't think I was ever able to resolve what specific type of device it was. It was always kind of a smattering. But when trying to query for fingerprint, whether the phone has fingerprints enrolled, if there weren't any fingerprints actually enrolled in the phone, rather than saying false, it would throw a security exception.
Oh,
so,
yikes!
Thanks, Samsung.
I know.
Yeah. So, a word of caution from those who have been there before is to definitely wrap stuff like that in handlers, because you never know what Samsung or some other vendor is going to throw at you with this kind of stuff that has deeper hardware interactions.
Excellent bit of advice there. So if we have, the Fingerprint Manager at this point in time, and we want to start, we're ready to implement this. How do we go? We talked about the public-private key pairs and the crypto and that stuff. How do I go about actually generating those? Like myself and a bunch of other folks might consider ourselves to be security dolts. So if you could maybe walk us through what that would look like to maybe generate a public-private key pair and kind of how to get it set up.
Yeah. So Android has a couple of classes that help you create and save keys to straight to the key store. And so there's the key generator, which is if you're going to be doing symmetric cryptography, which is to say like the same key will encrypt and decrypt that piece of data. And then there's also a key pair generator, which lets you generate public-private key pairs for the public-private cryptography. And so the flavor of which of those classes you're going to use depends upon what method of crypto you're doing and what your use case here is. So, for instance, if I'm going to be just signing data rather than encrypting it, I'll still want to use a key pair generator because that'll allow me to sign data with my private key and ensure that the only way I could ever sign it is if I put my finger to that reader. And so the way we do that is you pass in what's an instance of this class called a key gen parameter spec. There's a lot of words there, but what it actually does is it kind of wraps and encapsulates all the parameters for creating a key. And so it comes with a builder, and the builder methods come with things like what algorithm you might be using for the encryption, AES or elliptic curve or things like that. How many bits in the key. And then also one of those builder methods is, after you've kind of decided your algorithm and your key complexity is going to be set user authentication required. And so this is what puts that key behind the vault, so to speak, that's guarded by the fingerprint reader.
Got it. And okay, so that's basically like step one, I suppose, right? Like where you've generated this key and then you've managed to take this key and store it inside this the trusted execution environment, so to speak, but using the API, so you don't necessarily have to like do it yourself, right?
Right. Yep. And so then now you kind of figure out what you want to do with this key. So one thing that's really handy for using fingerprint authentication to a remote backend is that you can actually sign a piece of data like a request with your private key. And so that actually authenticate, if the only way that you're able to use that key is if you've used the fingerprint reader. So if I want to prove to a backend server that I put my fingerprint on there, I can sign a piece of data that's, with that private key, and then the backend can register it. So for instance, maybe I'm going to go and add fingerprint authentication to my app that has not had it before. So in the past, you would sign in with a username and password and you'd get back a session token. Well, you could go and sign a request with your session token and your public key wrapped in that as well, and send that up to the back end to register your public key as part of the data we maintain on the back end for your user. So then the next time around, if you send a login request, but you don't send in
the username
and password, but you send in, you don't send that, but you do send a signed blob of data with that private key, saying I want to log in as Don, and I'm signing in with my private key. Then you can validate that signature on the back end and say, okay, well this passes the signature, by verifying the public with the public key, and so I know that he actually has access to that private key, and so I can go and log in using that request instead of a username and password. And so what's really handy there is like if I go and I request with to enroll my device in this new backend feature, I can give back a device ID that I save locally. And so what's kind of handy is if I'm on the backend side, I now get the ability to revoke an individual device login.
Oh, I see.
And so since I'm not sending credentials over the wire anymore, a live username and password, I can go and remotely disable that device's ability to log in with Fingerprint and give you a little bit more security for your users that way, if they lost their phone and maybe somebody else might have access to the fingerprint. A really good analogy is if you've ever used SSH to log into a server.
Got it.
With and you've enrolled your public key on the server side.
Exactly.
And then you just kind of turbo log in. That's like pretty much the exact sort of thing we're doing here.
Exactly. Okay. So actually it brings up to like two quick follow-up points that I wanted to bring up. So you mentioned off the hand about symmetric and asymmetric cryptography, right? So just to give folks like a quick understanding, symmetric and asymmetric are like two mechanisms, but the difference is with symmetric, you can use the same key to sort of like unlock and also like lock, I suppose, right, with the same key. But with asymmetric, and correct me if my understanding here is wrong, guys, but I think asymmetric is where you have two different keys to sort of like lock and unlock, right?
Right. So with a asymmetric key, you have a private key and a public key.
Right.
And that private key you guard with your life. That is yours and yours alone.
Right.
And so I can go and you can send your public key, post it on Twitter, mail it to everyone in the world, because they actually need that to be able to encrypt data that's destined for you.
Right.
And so I can go and encrypt data using your public key, and now that data is your eyes only, and then you can use your private key to unlock it. And then what's also handy is that you can use your private key as like almost like a digital notary stamp. I can go and sign a piece of data with my private key, and then you can come back and validate that if you have my public key and confirm that it was really me who was the one who signed it.
I mean, for folks who worked on the web and SSH and like tried to like secure their site with SSL and all this stuff, this would seem a little familiar because the mechanisms are very similar, right?
Yep. Yeah.
And if folks are really kind of trying hard to wrap their head around how public-private key encryption works, and if you've never really dived into it, it can be a completely confusing beast. I'm going to put a link in the show notes here to a Medium post. It's only a 4-minute read, so definitely worth your time, where the author explains very easily in a great analogy how public-private key encryption works. We'll post it in the show notes. Definitely take a look at it.
My last follow-up question was, okay, so you mentioned about this back-end stuff where you send it to your back-end. So that brings up the question. So does this mean fingerprint authentication only works with when you're online? Like, what if I'm offline? Does it not work then? So like if I'm using an application and I'm, in a tunnel going in a bus, then does that mean I cannot use the Touch ID?
So one thing you can do if you don't actually care about having this implemented in your backend side is you can go and use you can encrypt a symmetric key to save data that you're going to store offline and also use that. So for instance, maybe I've got a diary app, just for a contrived example here. I could use a symmetric key to encrypt every piece of every single journal entry. Maybe I'm using Realm to actually back this up, as Don kind of suggested earlier. So I could use that locally saved symmetric key to encrypt some local data and pull it back up later on if I'm offline, or if I don't want to have any kind of server interaction at all.
Mm-hmm.
Oh, interesting. All right. So just to like wrap this up, so we have signed the critical requests with a private key. What happens after that? Like, so how do I have this key? What do I do now? Right? Like, I imagine I have to use like one of the APIs that's provided to me by Android. So like, I imagine this is sort of like the final step. So what happens here? At what point do I get like a Boolean saying, yes, you're authenticated versus no, you're not authenticated, right?
Yeah. So once you've got your key, and you've set this up, and either you've created it first off and you're going to use it, or you're coming back for it later, you can call authenticate on an instance of the Fingerprint Manager. You pass in what's called a crypto object, which is really just a generic box to put in a handle to the key. And that just kind of abstracts whether you're going to put in a key pair or a symmetric key that you want to be able to unlock. And so what that will do is it will activate the fingerprint reader. And when you call this, you pass in a callback. There's a listener that you implement. And so depending on how that scan went, you're going to get some calls into this. So, there's a success callback that gives you your crypto object back that's been blessed by the fingerprint reader. And so this has, you can pluck your key handle out and go and use it to sign some data or encrypt it. And then there's a couple different flavors of error conditions that are handled by two different callbacks you're going to implement. So one's for like a hard error where maybe you scan the wrong finger 5 times. And it locks it out. Like, try it on next time you go and try and log into your bank or your unlock your lock screen. 5 bad tries and it locks out the hardware. Another example though is a soft error. So there's a handler for that. So maybe you moved your finger too quickly on the sensor and it asks you to try again. I think we've all seen that one. There's another one in there that can get triggered, and this kind of goes back to the hot wing example here. There's a finger too dirty error condition as a soft error that says, I guess, go and use a different finger or go wash your hands or something. And
take a bath.
Yeah. What's really handy, though, with these soft and hard errors is that you don't actually have to worry too much about disambiguating what the error is. So Android is nice enough to pass in a string into these callbacks that actually has the localized error text that you can show in your UI. So, maybe this is also because some vendors and OEMs might have their own, failure cases for why their sensor didn't work. And so they can go and handle that and you don't have to worry about it. Or, you want to have localized to your language, and you don't need to enumerate localized translations for all these different error conditions, things like that. But one thing you'll find in the material guidelines about how to lay out your UI is it's going to tell you to use what the framework gives you back in those callbacks, and don't try and dream up your own error messages.
Nice. Okay, that makes sense. So just to wrap it up with what you just said, you have this crypto object that you pass it with the Fingerprint Manager, at which point essentially like the device starts listening into your fingerprint ID. Once the person sort of like puts his finger on that sensor, essentially the data comes in, and the callback that you also passed in initially when constructing this comes back with the success or failure, and then you can perform accordingly what you need to do there. Is that like a sort of like high level summary?
You got it. Yep. And if you get the success, then you can go and use that key to encrypt or decrypt some data or sign something. At that point, the key is yours to use.
Now, there's a ton of stuff that seems to be out there for the various different fingerprints. There's the Android documentation and so forth, but I wanted to highlight some of the things that we've noticed and some of the things that you've done, Ben. One being you have an actual Android fingerprint demo up on GitHub. Is that correct?
Yeah, I put this together for my talk at Droidcon New York last fall. So what you'll find in there is a super simple implementation of an app that does fingerprint. It's sort of, I did Uber, but for baked potatoes. I call it Tuber.
Yes.
And what you'll find in there is a sample app that uses the Fingerprint APIs, and then also a sample backend that handles the public key verification. So if you wanted to use a signature-based request pattern, you'll find some, a starting point in there. And so you can pretty easily spin up that backend. It's all lovingly done in Kotlin.
Oh, nice.
And you can run that locally and run the emulator as well, side by side, and there's some instructions on how to actually make sure that your emulator can talk to that sample backend, and you can roll around and play with the fingerprint there. And then you'll also find in that same repo that we'll have in the show notes, there's my talk from Droidcon, all my slides with some actual code samples if you don't feel like looking through the example.
Great. Yeah, so we'll put that in the show notes. For folks interested, we'll put a couple other links in there as well. One for the Android hardware keystore link for the Android documentation and so forth, and also that great iOS security guide that you were talking about, which is that white paper that's just a good read. We'll put that in there. And finally, there's also a open source library by the folks at Square, not surprisingly, and this one's called Whorlwind. So it's a reactive fingerprint library that you can use. We'll add all those to the show notes here. Ben, I'm really excited to check out that GitHub link of yours. I didn't know there was a server component to it as well, so I'm going to check that out and fork it and probably create a Uber for Chipotle because I need some burritos stat.
Yeah. Burrito bowls
All
on
right.
the go.
Dude, totally. Here's my money. Just take it.
Ben, thank you so much. This has been really exciting. This is like, it opens up like a whole bunch of possibilities, and I'm sure many folks who are curious to see what's involved to like sort of implement this fingerprint authentication, this is extremely useful stuff. Thank you so much for coming on the show and like helping us understand this stuff.
Yeah, thank you.
Thank you very much for having me on. I hope this is a good starting point for a lot of people.
Absolutely. And if folks want to reach out to you, like if they want to find out more about this fingerprint stuff, what's a good way to do that?
So definitely check out the GitHub repo in the show notes. And then if you have any questions, you can hit me up on Twitter. My handle is Ben Lights to Code.
Nice.
And I'll be happy to field questions on Twitter, for sure.
All right. So folks, Ben likes to code, and Don, I know you like to code as well. So where do folks hit you up?
Just like Ben, well, on Twitter, you can hit me up at DonnFelker. What about you, Kaushik? Where can folks find the illustrious Kaushik Gopal?
Well, I have a very creative Twitter username, and it's KaushikGopal at Twitter. So, so folks can hit me up there if you have any questions. Thank you all so much for listening, and thanks again, Ben, for coming on the show.
Thanks, Ben.
Thank you.
And you can catch us all in the next episode. See ya. Once again, we want to thank Rollbar for sponsoring today's show. With Rollbar's monitoring systems, you can see what errors lurk in your code. You can detect, diagnose, and debug production errors with complete ease. Just remember the tip that I mentioned if you want to clean up your code. We have a special offer for Fragmented listeners. Go to rollbar.com/fragmented, sign up and get their Bootstrap plan for free. Thanks again, Rollbar, for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by DonnFelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.